In this video, we're going to be going over points, lines, and planes. So we're going to describe what they are and what they look like. So first off, a point indicates a location. And points actually have no size. So when we draw them as, a little dot, but they actually don't have size. So it's almost impossible to draw a point because all of these points have no size. And we're going to name them by just a capital letter with the dot. So just capital letter and a dot. Then we have lines. So for lines, it's going to be a straight path that extends in two opposite directions without end. And it has no thickness. And it contains infinitely many points. So when we draw a line, it's actually going on and on forever, which is why we have those two arrows, but of course we can't draw something like that. And this line contains infinitely many points. So there's a bunch of points on here. We might name them A, M, B. And there's a few ways to name this. So the first way is you pick any 2 points and you draw an arrow over them. So A, B, B, A. You could say A, M, M, B, etc. We also can name it with a cursive letter. So we might call this L, so this could be line L. What we're not going to do is name it with all 3 points because that just gets to be too much. So this one we're not going to do with 3 points. Then we get up a level to a plane. So a plane is a flat surface that extends without end, and it has no thickness, and it contains infinitely many lines. So we're going to draw a plane kind of like a piece of paper. So think of it as like a flat piece of paper that goes on and on forever. We can first name it with a capital letter. So we might name this one like capital letter P. So this is plane P. And we can also name it by 3 points not on the same line. So let's try. We'll draw 3 points, A, B, C. And we might even have an M. We can't name it A, M, B though because they're on the same line. So think about trying to make a triangle. So plane A, B, C. And so for this, I would say think about trying to triangle because then you know they're not on the same line. Next up, we have a segment. So this is a part of a line that consists of 2 endpoints and all the points between them. So it might look like this. A, B. And we're going to name it by its endpoints. So we can either say AB or I can say BA. Notice this time I'm not putting arrows like I did for the lines. I'm just putting a straight line. Next up I have what's called a ray. So a ray is a part of a line that consists of one endpoint and all the points, on one side. So let's try to draw a picture. We can have these 2 points A, B, and I want all the points on one side of A. So everything from A to the right, or I could have my 2 points A and I want everything to the left. So I draw everything to the left. You have to name this by the endpoint first, then another point. So this first example, which I'll re-highlight in pink, is AB with the line to the right. The second example is BA with the line to the right. So with rays, you might think, well, why didn't I draw it like this? Or like this? So we're not going to draw the arrows to the left. We're just going to start with the endpoint, go to the other side, put the arrow to the right, no matter which way the arrow is actually going. Our last definition is an opposite ray. So this is 2 rays that share the same endpoint and form a line. So let's see what this looks like. We might start off with this point C, and that's going to be our endpoint. Then I have this one ray that's got an A on it, and I've got this other ray that's got a B on it. Notice how when I combine them together, I form a line. So this first ray, we start with the endpoint, and this is CA. This second is CB. And so CA and CB are our 2 names, and you always start with the common endpoint. So we've now got a few more definitions. So collinear points. If you think of the word co, like a co-worker, you think of the word same. And if you think of the word linear, you might think line. So what do you think same line points are? Well, they're points that lie on the same line. So if I draw this line and it's got A, B, and C on it, what we might say is A, B, and C are collinear. Now, what would you think coplanar means then? If you guessed same plane, you'd be correct. So it's points that lie on the same plane. So if I draw my piece of paper like my plane, I've got A, B, and C on it, I would say A, B, and C are coplanar. Now let's look about the kind of questions we might be able to answer with these problems. So what are 2 other ways to name QT? Notice since I have the arrows that this is a line. This is line QT. So I'll look at QT. Well, it looks like it's this line right here. So I can name it by any 2 points on that line. I could name it TQ, making sure I draw the arrows over it. I could name it NT. I could name it TN, or I could name it this like cursive undercase letter, lowercase letter m. What are 4 other ways to name plane P? Well, plane P, I just have to pick 4 points that form a triangle. So maybe R, Q, and V form a triangle. So plane RQV. Let's pick 4 other points. What about R, V, and S? So plane RVS. What about plane QVS? Or plane RVQ. You can just switch the letters around, right? Then one I can't name it is RQS. And that's because these points are collinear. So I can't name it that. And it's just asked, what are the names of 3 collinear points? Well, I just told you, RQS. Another set would be this line on line M, TQ, and N. What are the names of 4 coplanar points? So this is asking, what are the names of 4 points that are on the same plane? Well, if I look at plane P, I've got R, V, Q, and S. Another question asks, what are 2 other ways to name line RS? Well, if I look at line RS, that can be named with the cursive L. That can be named with other points on it, so like QS or SR. And there's some others too. What are 2 points that are not coplanar with points R, S, and V? So what points are not on the same plane? Well, if I look at R, S, and V, they're all on this yellow plane that I have. So points off of it are like T and N. Next up, I could look at some segments. So what are the names of the segments in this figure? As long as I pick 2 points and draw a line, I could draw one like this as well, that could be a segment. So I've got DE, I could switch the letters around. I've got EF, I could switch the letters around. I've got DF, and I could switch the letters around. And remember now, since it's a segment, I'm just going to use a straight line over it. I'm not going to put the arrows because it's just that little chunk of the line. For rays, I can do the same thing, but just extend it onward. So I'm just going to take all the line segments I wrote and say, well, this could just be something that extends past that point. Now it asks, which of the rays are opposite rays? So let's look at what we have. I need 2 rays that form the whole line. Well, my common endpoint might be E. So I need 2 rays that start with E. And I could have ED and EF. And those share the endpoint and form a line. This next question asks, EF and FE form a line. So let's see which ones we're talking about. EF is here. And FE goes like this. So they form a line. Are they opposite rays? Explain. So maybe take a second to pause and think about this. They're not opposite rays because they don't share a common endpoint. Now here is a statement that we have that's called a theorem. So, through any 2 points, there is exactly one line. So what is that saying? If I have 2 points, and I ask Joe to draw a line through them, and he draws a line like this, and then I ask Sam to draw a line, and she draws a line like this. There's really only one way to draw a straight line, so they drew the same line. Now, intersection. An intersection is the set of points that 2 or more geometric figures have in common. So what does this look like? Think about at a street intersection. It's where the 2 streets meet. So if I have 2 lines and I want to know where they meet, well, they look like they meet right here. So they meet at a point. And in this case, it's point C. Now look at where these 2 planes intersect. They actually overlap each other in a line. So in this case, it's that line ST where they overlap. So now we have a box and we can answer a few questions about it. The first question is, what is the intersection of planes ADC? It's really helpful at this point. So ADC is this, which means it's the top of the box. So use a highlighter. And plan FBG, where do they intersect? Well, the side of the box and the top of the box, they look like they intersect in this line right here, which is line BC. What are the names of 2 planes that intersect BF? All right, let's erase this. BF is this right here. So the 2 sides of the box would form it. So this is plane, we could say BFE, and plane CBF. So it's the 2 side planes, which you could name in a few different ways. Finally, the last question asks, what is the intersections of line FG and CG? If you look at these 2 lines, they only hit each other at that one point. That point is G. Now we have another theorem. So it says, through any 3 non-collinear points, there is exactly one plane. So think about what this is saying. 3 non-collinear points are points like R, Q, and S that form a triangle. If you think of a plane as a flat piece of paper and you're drawing a flat triangle, there's really only one flat surface it could lay on. So that's why for 3 non-collinear points, we only can draw one plane, which is why we choose 3 non-collinear points to do that. Our next question says, what plane contains points N, points P, and points Q? So let's look. Well, it's the bottom one. So this is just, we could just even name it plane NPQ. Now here's a tricky one. Which plane contains points J, M, and Q? So we need something that goes from the top corner to the bottom. So if I try to connect this, I know this has to go through it, which actually means it's this kind of slide. It's this ramp that goes down. So this is plane JMQ.